Hello. I can't believe that so many of you voluntarily walked into the doors are now locked, so, there's no escape. We only let people in. Anyway, I'm Gerald, and you've come to hear me waffle on about a love letter to legacy. Now, first of all, I'm legacy, really. I mean, I remember Java 1.0. That's how old I am. When lambdas used to be called and were anonymous classes. Who remembers that? A lot of legacy in here as well. So this talk is about me talking about legacy, which I actually find quite exciting. Now, let me explain why. What is legacy code? I mean, if you've paid attention to the news, there was a small breach of Oracle who decided that it's not the Oracle Cloud that got breached, it's the Oracle Classic Cloud. So that was a masterclass in breach notifications. Anyway, what is legacy code? As I was talking to Rick before, he reminded me that Michael Feathers has got a very neat definition of legacy code, which is that code that isn't tested is legacy. Because if you can't test it, you can't trust it. So, I've been a developer by trade for quite a long time, legacy. And when you get given a project, not in a source code repository, but as a zip file, that's legacy code. When you look at the tests that are in there, that cover about a third, but all of the asserts have been commented out, so they don't actually test anything, that's legacy code. So code without tests is legacy code. But I'd take that a little step further. I'd say that code without tests that you can trust is legacy code. Because just because you've got a test folder and, you press a button and you run it and it says green, doesn't actually mean that you can trust those tests. If you've been given that zip file, and if you've been entrusted with that and said, right, now make changes, it doesn't work like that, does it? You have to then understand what the tests do. And again, I'll take it one step further. Code without tests that anyone can trust is legacy code. It makes no difference if you can trust it, because, it's a legacy system. You're only going to be working on it for a year and a half, and then some other lower bidder will come along and look after the legacy system for you. I'm not bitter. I'm not bitter at all. Some of you, I know some work in security, we tend to be quite observant. You might have noticed that I sneaked some classic cars in my previous slides. And classic cars are quite valuable these days. If they haven't broken down and rust away in a garage. It's actually an interesting thing, because sometimes people struggle to find a name for legacy because they don't want to call their legacy system legacy, because it's a swear word, isn't it? I have to work on the legacy system. However, I've heard abominations like vintage systems or heritage systems, and that's just ridiculous. But at the end of the day, going back to the value, when you look at a lot of systems, legacy systems sit behind a huge amount of our daily lives. You wouldn't be able to do anything in government without some mainframe somewhere. You wouldn't be able to do anything with your bank without some legacy system in there. Now, why is that? Because they've been there for 30 years and they've worked. That's actually not a swear if something is really old. If something's really old and it still works, that deserves some applause, doesn't it? just because it's not the latest shiny. I mean, I don't know how the organizations that you're in work, but I'm sure a lot of you at the very back have got some legacy system sat there, or at least an organization that works with a legacy system that you really, really need. And remember, legacy doesn't just mean COBOL. Legacy can mean anything. You know, if you've got a 12-year-old Java code base that nobody's touched for a long time, that's a legacy platform. Another way of thinking about it is that complex code is legacy code, or it will be. The thing that you develop today is tomorrow's legacy code. If you start developing using vibe coding, like the cool kids these days, are you really going to add tests? Are you really going to understand those tests? Are you really going to trust those tests? So you're vibe coding instant legacy systems. Now, how's that for a use for AI? It'll keep me in a job for quite a long time, I'm sure. So what usually happens when we deal with legacy systems? What usually happens is that somebody goes, oh, I have to be on support for this crap again. And you also can't hire for it because nobody wants to work with a legacy system. And there's metaphorical gaffer tape involved. Sometimes it's not metaphorical gaffer tape. One of my favorite anecdotes from working at HMRC is the anecdote about the Swansea data center that had a mainframe that got flooded, where the floor gave way, and the mainframe was held in place by its network cables. So when they sent the contractor in to, fix the floor and undo the damage, they told the contractor, no, you can't unplug those cables because the system is still working. So they had to hoist up the mainframe, build the floor underneath it, and then, It's funny how legacy systems can survive this kind of thing. And I think that's a really nice metaphor. I call some of the problems with legacy the maintenance death spiral. And it doesn't matter at which point you start, you're sort of going round in circles. You end up with something that because, you've been given the support of a legacy system, you don't really know what you're doing. So you don't really want to touch it. Because you don't touch it, you don't have any improvements. And because you don't have any improvements, inevitably all the people who deal with it get bored and want to move on, which then means that you've got poor system knowledge, because any masochist like me that works with legacy ends up kind of going, no, I want to work with something else. So maintenance death spiral. It's a bit dramatic, but, nobody creates legacy code intentionally. There is a metaphor called Chesterton's fence, where you have a fence that you don't know what it is. Now, do you just tear it down, or do you leave it there and try to understand what it's for? Because the people who have put it there initially will have had a reason. A lot of the problems with legacy code is simply down to the fact that people don't necessarily understand the context in which something was built. It's very easy to say, this system is shit. They didn't use this, they didn't use that, it's some horrible monolith. But put yourself into the position of when systems were originally created and things start making more sense. It's easily forgot. Yeah. Well, no comment. Nobody wants to touch it. Legacy systems usually have got very old problems still in there. And like Oracle found out, when you don't fix outdated software and leave it on the internet, somebody will pop it. Now, I want to step back a little bit. I want to talk about metaphors because it's very easy when talking about legacy system, to have this in your mind. That legacy system are sort of brownfield development, and when you create new software, that's greenfield development, where you have fantastic security pipelines, where you have build systems that block anyone from doing anything that might be considered insecure. Because that's exactly how startups build their code, isn't it? Oh, wait a minute. No, it isn't. One of the things that you always find with greenfield, again, it turns into legacy because you need to build something fast because it's a startup and you kind of think that you can cut corners, and then you spend the next 2 years fixing all the problems that you've created on that brown field. But in terms of the name of it, just when you think about the name brownfield, you don't want to go work in a dusty old coal mine, do you? You want to work in the sunlit uplands of shiny software architecture. I think that is a better metaphor, a cathedral. Legacy systems, the big systems, they have survived for a long time. Okay, maybe some of the plans were lost in the midst of time because you've handed over support to an external company, then you outsourced it, then you brought it back in-house, and none of the people who ever wrote most of the code are still around, shall we put it that way? Some of the skills are sometimes not available. I mean, who here knows what a war file is? You know what a war file is, right? Yes. But these days, we have microservices and things. We don't need war files anymore. But when a legacy system needs a war file for deployment, the web archive file, sometimes you get problems that are like, I don't understand what that is, so I'll just not touch it. And yes, they did know what they were doing then. So it's rubbish, isn't it? I mean, it's old. It's no steel, no glass. It's the Sistine Chapel. Just because something is old doesn't mean it's bad. Just because something is old doesn't mean you can't stick something modern in it. I'm coming to the place where I'm saying, I think that when systems get modernized, you can unpick the complex code. You can add some testing to it. Maybe you can't turn legacy code completely into non-legacy code anymore, but you can certainly build up a nice understanding, and you can carefully make changes. Of course, when we talk about legacy development, that's what usually is mean when you introduce a new pipeline. You have the security pipeline, and then something doesn't work, so you just say, we'll switch it off for a week, or a month, or a year, or forever. It's a problem with some of the things where you think you're putting in improvements, and you kind of go, I can just block stuff until the VP of sales says, no, we need this now. Applies to general software engineering. You also have the alignment between development and security often. It's very easy for developers to say, the other year I heard developers saying when security tried to introduce a WAF, it's not that we put the WAF in blocking mode, we put it in breaking mode. And every problem with the application was suddenly, it's a WAF problem. And vice versa, security tend to look at developers, these idiots don't know what they're doing. It tends to work a lot better when you sort of align, when you have some independence, but you're still pulling in the same direction. Now, let's see. So, as you might have guessed, I have worked on some legacy code. And that's what it looked like. Okay, we might recognize that this is from pre-COVID times. The legacy way of working, if you like. But the interesting thing was that we had a legacy system which a lot of you will have used because it's the like HMRC's way of paying taxes, self-assessment. And that was said 12-year-old Java codes that came in a zip file that you needed to work out what it did before you could actually try to maintain it. And we split things into 3 sort of swim lanes. We dealt with all the bugs, but we also made improvements from new features and actually improving how it works. And it's the same thing for application security. If you want to make changes, if you want to improve things, you can't just say, right, we're stopping everything, putting a new system in. You have to make incremental improvements. Now, inevitably, the question comes up, should we just take this big ball of mud, this legacy system, and rewrite it, because it'll be so much better? You can probably guess what I'm going to say. You know, I mean, these are the things that people often say, yeah, we need to rewrite it because then we can do it properly, we can consolidate our tech stack, we'll bring in a new team to build it, because that always works well when you bring in a new team to build something that an existing team then continues to maintain. I guess there has been something in the news recently that, I think they said they were going to rewrite it in 6 months. I don't think so. I don't think you should just go and say, we'll just rewrite everything. It hasn't worked forever. When Netscape was trying to rewrite their browser, they're replacing everything. They basically then lost all market share to Internet Explorer because it took them much longer than they thought. And the same story has been repeated time and time again. Now, I'm not saying that you can't ever get rid of legacy systems, but you need to look at them to sort of say, you know, where can you make the improvements? Can you make small improvements and phase things out? If you try to think of it as one big thing that you can just lift and throw away and put something new in, that will inevitably almost never work, in my opinion. Now, I've talked a bit of about legacy, and now I'm going to tell you what legacy gave to me. Because it is something that, actually, I worked at a system, I sort of hinted at the name, HMRC, and that was like 7 million lines of Java code, and no one human being can understand everything that goes on in the code. So it is quite impossible to just sort of go and say, right, we can rewrite everything without understanding all the side effects. But digging into specific things and trying to work out all the idiosyncrasies of the system made me quite good at trying to read code and find problems. In fact, it made me so good that I started finding security issues, which then led me to change over into application security, which was a lot of fun. It also showed me that not all of the solutions are technical. Sometimes you don't want to go and say, right, we need a new piece of software for something. A skill that I think we might be losing now that vibe coding is everywhere and we just create new tools, legacy instantly. And I also found that when you can work in an agile way, which doesn't mean Scrum, it doesn't mean Jira. I think Martin Fowler said that agile is very often confused with working in sprints and having Jira. But if you can work in small steps with quick feedback, it is something that you can do, whether it's a shiny new system or an established, proven value old system. So yeah, what did we do in this talk? We sort of tried to define legacy. I My big invention is the maintenance death spiral. Probably not my invention, but language matters a lot when you talk about legacy system. If you go and work on a system and say it's a legacy system and go in with the mindset, it's shit, you're not going to see the value because you kind of go, oh, it's not the thing that I'm used to. Don't just rewrite it, and it can give you a lot of joy working in a legacy environment. And that's me. Thank you very much.
Great memes, by the way. Love that. We've got time for a couple of questions.
Absolutely.
Anyone got a question? Don't be shy. Or you could be shy and ask that.
Yeah.
Do you think ultimately changes in standards like SBOMs and stuff are going to kill legacy systems over time? Because nobody will be able to uncover the information that needs to satisfy those standards.
Oh, that's a very good question. It's a tricky one because I mean SBOMs are great for asking questions, because you have a dependency that somebody says, yeah, there's a vulnerability there, doesn't necessarily mean that you need to fix it, because it always depends on the context of the way that you're using things. And I think one of the things that you find with legacy systems these days is that most of the time they tend to be surrounded by more modern front ends. So a lot of the things that in a modern front end you can't get away with, sometimes if you assess the risk, this is on an internal network and you've secured it properly, that's obviously a big if, then you can still sort of decide, well, this system is providing value, this system is going to give me a chance to do things. It might not be the thing that you turn your attention to immediately. One of the things that I would recommend people who start out in software engineering is to learn COBOL. Because all the people who maintain the existing mainframes, they're, 70? Getting big, fat, juicy contracts because nobody else can understand it. The idea that AI is just going to replace everything with complex systems with millions of lines of codes and finding every intricate thing without hallucinating, I think is wishful thinking. So the sort of, yes, it's a difficult thing to deal with a legacy system. But in HMRC, we were stuck with old versions of libraries, old versions of framework that ended up not being supported anymore because so many things go out of support so quickly. But there were sort of open source things, they worked, we sort of loved and caressed them and cursed them in the meantime. But it was something where we understand the weaknesses. And a lot of the time, when you look at vulnerabilities, 95% of them, I think Jerry Gamblin gave us the stat once, 95% of vulnerabilities are never even exploited. So it is a question of, if you just want to do, here's my security pipeline and we can't have any CVEs, that's never going to happen with a legacy system. But I would argue it's also never going to happen with a, shiny new system. I've not answered your question, but I've spoke a lot. So
I think we're at time, everyone. So if you've got any more questions, feel free to chat to Gerald after. But thank you so much.
Thank you.